All right, hello, this is Mr. Crozier. I'm going to do a solid of revolution problem example. We have this equation here, y is equal to 4 minus x squared. And I know that's an upside down parabola just because I know my parent functions. And I want it revolved around the x-axis in quadrant 1. So let's kind of sketch this out, what I have here. If I plug in 0, well, that's 4. 1, 2, 3, 4. There's 4. And if I plug in 1, that would be 3. If I plug in 2, that would be 0. So right there's my parabola. 1's 3 and 2's 0, and it slopes down like this. And that's the area in quadrant 1. Now let me just double check this. 4 minus x, 4 minus x squared. Let's go from 0 to 4 just to make it interesting. And 0 to 6, and we should have that graph, and there we have it. All right, so what we're going to do is set up our integral from 0 to 2, because that's the amount in quadrant 1. And I'm going to build rectangles that are going to work real nice like this. So there's my rectangle, and I'm going up and down, and this is dx, and the height of this is, let's call it f of x, or that function right there. So if I'm going to do this as a revolution, though, however, it's not just this area. It is this volume. If I were to draw this symmetric across this axis and then draw these revolutions in here, so I'm going around, and everything is going around and around and around and around and around, and it's going to make this cone shape right here. So now instead of just being a flat area, it is revolved around here. So it's this cone that goes all the way down there. And that's what I'm looking for. And a lot of times I'll draw this last one kind of nice and draw those there. So I'm drawing this cone-shaped object that's being revolved around there. Well, what is this? Well, it's no longer length times width. Now it is a circle times the width. And that, of course, is pi r squared times dx. So we have a circle times our width. So let's go ahead and do this. So I say, well, how can I integrate this? Well, let's pull this constant pi out to the front. Don't need that. And what is my radius? How high is it? Well, that's how high it is. It's right there. So this is my radius squared dx. And there you have it. Now all we have to do is integrate that. Now I could just hit Math 9 and plug that in, put a pi out in front of it. I could go out there and put that pi out in front and go 0 to 2, 4 minus x squared, dx. There's the answer I'm looking for. It's the answer I'm looking for right there, 16.75. That's the answer. But let's go ahead and do it. Show the work that you'd have to do. Well, what I'd have to do is, let me go ahead and FOIL this. That would be 16 minus 8x squared plus x to the 4th dx. And now that I have that, well, now I can integrate it, right? And I could integrate it and say this is 16x minus 8x cubed over 3 plus x to the 5th over 5 over here. And now this is where it's okay to just use the fundamental theorem of calculus that says, not 20. I'm going to do these two problems. I'm going to subtract that upper distance minus the lower distance, and that lower value, that's just 0 if I plug in 0 through this. Don't forget we have a pi out here. Now I'm going to plug in 2, so let's see here. 16 times 2 minus 8 times 2 cubed divided by 3. And you can do this with a scientific calculator too. If you have a scientific calculator, divided by 5. And that's 17.6. Let's go and make it a fraction. That's 256 over 15 times the pi, 256 pi over 15. 256 pi divided by 15. And there you have it. Oh, whoops, I forgot think we made a mistake on our original integral. Let's do that right. Let's put this pi out here. Oops. Let's put pi integral, oops, 0 to 2. I think I know what I did wrong here. We forgot to square that integral. There we go. Now we have that, and 256 pi divided by 15. And there you have it. Both of them are the same. So there's how you do a solid of revolution. The key is this is your integral. It is no longer length times width. It is now the circle times the width. So that length becomes a circle because I'm dealing with circles. I'm still dealing with dx here, but now I have circles all the way. So it's the same formula, same kind of step, just change it to this first and go through this math. And again, when you go from here to here with a scientific calculator or a calculator, I don't need to see all the fraction work. Just write down first one minus the second one, pull that pi out. All right, hope this helps with your solids of revolution.